Hi guys, welcome back. It's Saxon 7.6 for my 6th graders. If you're following along at home, it's Saxon 7.6, the 3rd edition. It's this lovely yellow book. Today we're going to be talking about lesson 2, which is not adding and subtracting, multiplying and dividing whole numbers and money, as far as money goes, and fact families. Now, this may seem like a repeat to a lot of you, and you probably already know how to do a lot of this, but I am going to introduce you to a different way of multiplying today. Now, it may not be your favorite way, or you may find that the old way is easier for you, but there's a reason why I'm going to introduce this to you. And that reason is that it comes in handy later on in algebra. So let's get started. All right, so taking a look, if you're following along at home, I'm on page 6, and we're going to talk about some of these examples. Starting with number 1, we have, the other thing I wanted to talk about that you will need are for product for your notebook. If you are one of my students, you should be following along in your notebook in the section labeled notes or videos. This is a good definition that you'll need. Product equals multiply. Quotient equals divide. So we know from the previous lesson that sum is adding, difference is subtracting, and now we know that a product of two numbers means to multiply them, and the quotient means to divide them. Okay, so those are important. All right, so let's start with our first example. We have 35 cents times 24. 35 cents times 24. And again, if you remember from my previous example, 35 cents, notice there's no decimal in there. Otherwise, we would be saying a part of a cent. Good. So the old way that you may be familiar with multiplying this is we take 5 times 4, which gives us 20. Then we do 3 times 4, which is 12, plus 2 more is 14. Okay. Then we bring down a 0, and now we do the same thing, but we're going to wipe this guy away. We do 2 times 5, which is 10. So we put a 0 here and a 1 back up here. Okay. And then we do 2 times 3, which is 6, plus 1 more, which is 7. And we add all these together. We get 0, 4, and 8. Now, because we are talking about cents, it's 840 cents. 840 cents sounds kind of weird if you say it that way. Another way of saying this would be $8.40, right? Those are both going to be the same thing. Now, the other method of multiplying is this. We still are going to do 35 cents times 24. This is called the box method. And like I said, this actually is really helpful when we get into polynomials in algebra. So I like to just introduce it now. If you like this, great. It takes a bunch of practice, but once you get it down, it's actually a lot faster. I do this now in my head all the time. So what we have is 35. 35 can be written as 30 plus 5, okay? The other number that we have is 24, and 24 can be written as 20 and 4. Now we're gonna multiply. 2 times 3 is 6 with 2 zeros there, right? 20 and 30. 5 times 2 is 10 plus that extra 0 there. 4 times 3 is 12 with an extra 0. And 5 times 4 is 20. All right, in our head, we're able to do this. 600, 700, 820. 820 plus that other 20 there is 840. 840 cents. So all I did is, just to recap, is I multiplied these guys, and then once I had my whole box filled in, I just added all of those together. And we get 840 cents, which I said another way of writing is $8.40. Both of these methods are perfectly fine for how you want to multiply. This might come in handy again when you get into algebra, so I like to introduce it now. And you'll see that I'll probably do my multiplication that way on all of my examples. If you have any questions about that, let me know. Okay, so let's talk about example number 2. We have 400 times 874. Okay, box method. Let's try this guy. It is a 3 by 3. So we want to draw a 3 by 3. That was a terrible box. What am I doing? Oh, goodness. Now up at the top we have 400, which is 400 plus 0, right? On the side we have 800 plus 70 plus 4. That's our expanded notation. If you don't remember that, let me know in class and we can go over that. All right, so 8 times 4, we get 32 with 1, 2, 3, 4 zeros. Now, when I'm doing these, I like to put a comma after every third one because it'll keep me nice and organized as I'm working along, okay? 4 times 7 is going to be 28 with 1, 2, 3 zeros, right? 4 times 4 is 16 with 2 zeros. Now, all of these zeros. 0, 0, 0, 0, 0, 0, okay? Because 0 times 800, 0, 0 times 70, 0, right? So we add all this up together, and we get 320,000, 28,000. Oh, there we go. I'm supposed to keep it nice and lined up. Let me fix those. My zeros were messed up there. And then 1,600. We add all these guys up. We get 6. We get 8, and 1 is 9. And then 2 and 2 is 4, and 3 over here. We have another 0, and we have another 0 like this. We put our comma right in there. And so the answer for this would be, oh, I just realized it was off the screen. I'm so sorry. 349,600. 349,600. Do you see how I've added those all up? My apologies, I didn't realize it was off the screen. Now, an easier way to do this, and this is what I also want to talk about, is, so we got 3,496,600. Perfect. Now I'm going to move this back down. I just realized my camera moves periodically. I'm so sorry about that, guys. Okay, so coming back up here, you may have seen me do this when I was doing the box method. Really what this is, multiplication is just like addition in that we can flip it around, right? So we have 800, see, I said it 800 and, you're not supposed to do that. 874 times 400. What this really is, and I want you to get in the habit of this, it's actually 874 times 4 with 2 extra zeros on the end, because this method is so much easier, right? 4 times 4 is 6, carry the 1. 7 times 4 is 28, plus 1 more is 29. And then 8 times 4 is 32, plus 2 gives us 34. And we get the same answer, same answer. So box method is helpful, yes. This is more helpful, especially with those zeros. Things like, you may have seen me do, if we did 70 times, let's say 2,000, right? We have seven, that's supposed to be 7. 7 times 2, which we know is 14. And then we have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And we get 140,000. 140,000. Hopefully that is helpful. So I've given you a couple different ways of doing this. If you got those excess zeros, just slap them on at the end. Forget about them until you do that. Okay. So let's look at we're going to be dividing whole numbers now. We're looking at example 3. If you're following along at home, this is on page 9. It is saying 3,456 divided by 7. First and foremost, I would like to talk to you about those commas. I rarely use a comma when we're talking just about like in the thousands, right? I start to kind of use them when we're talking about tens of thousands. Because then it's like, oh, if you get 5 digits in there, it's a little helpful to have that comma. So sometimes you'll see it, sometimes you won't. I definitely use it as I get up into the 100,000s. So things like 751,526, right? Did I just say and? I probably did. 751,526. Then in that case, yes, I'm going to use a comma so that it keeps things nice and organized. But in things like this, you may often not see a comma. Okay, now this guy comes in the front part of it. So it's going to go under our table, 34, 5, 6, divided by 7. Excellent. First things first, what we're going to do is we know that 7 can't go into 3, right? But it can go into 34. How many times does 7 go into 34 without going over? 4 times. Now, and notice how I lined it up nicely there. If you need to draw some lines to keep your columns nice and straight, that's okay. You'll get used to doing it without that, but if you need to, absolutely do. Now what we do is 4 times 7, that's 28. We subtract that. All right, we get 6 here, right? Because 34 minus 28. Mentally, let me just talk about how I did that. When I'm subtracting, I think of a number line, right? And I put my littlest number, so 28, and I want to go up to 34. Well, 28 up to 30 is 2. From 30 to 34 is 4, so that's 6. So that's how I got that 6 there. Now you could do it the old way where you borrow, right? There's a 2 and there's a 14 and then you get 6, right? But I just like to talk through what I'm doing mentally so that you can pick up on that. All right, now every time we subtract, we bring down a 5, okay? Or we bring down the next number, it happens to be a 5 in this case. Good, so how many times does 7 go into 65 without going over? Well, we know 7 times 10 is 70, right? So it's probably gonna be 9 times. 9 times 7 is 63. When we do that, we get 2, okay? Every time we oh, I should put a subtraction sign there. Every time we subtract, we also have to bring down. So in this case, it's gonna be a 6. And we're gonna do, how many times does 7 go into 26 without going over? It's gonna be 3 times. And then 3 times 7 gives us 21. We subtract and we have 5, so we have a remainder of 5. A remainder of 5, okay? So let's take a look at some of these other ones here. Okay. Okay, so the next one is, we've got down at the bottom of page 9, we have $4.80 divided by 3. $4.80 divided by 3. When we're dividing, okay, this guy here, that decimal always has to be at the end. And do you see? There's no decimal there, therefore it's at the end. So we're good there. Then whatever we have here, we're gonna bring that decimal up to the top, okay? Now 3 goes into 4 one time, and then we do 1 times 3 is 3, okay? We subtract that, we get 1, bring down an 8, 3 times 8, or I'm sorry, 3 goes into 18 6 times. 6 times 3 is 18. Bring down another 0, and 3 goes into 0, 0 times, okay? So we have $1.60, $1.60. Okay, so then we've got some other problems here. You know, and I'm noticing too that they do a short division. They do an example for short division in there, which is just doing the subtraction in your head. If you can do that, that's fine. I don't advise doing it until you're really, really comfortable with long division. So keep showing your work the whole way through, unless you know that you can do it in your head, then that's okay. Okay, so let's talk about those fact families. In addition and subtraction, we said, hey, one way we can do addition, one way we can do subtraction. The other thing that we can do is in multiplication. We can do one way multiplication, the other way division. So it's gonna work the same kind of way. For our first example, we have 5 times 6 equals 30. Now, just like addition, multiplication can be flipped around. So this can be 6 times 5 equals 30. I'm gonna put that down just a little bit further. 6 times 5 equals 30. All right, so in this way we multiplied, which means in this way we divide. And when we do that, we get 30 divided by 6 equals 5. You see that? All right, in this way we multiplied, which means in this way we can divide. We get 30 divided by 5 equals 6. 30 divided by 5 equals 6. It's really important that you understand these, because later in the book they start putting in variables, and variables are letters that we use in place of numbers. So it gets a little bit trickier when you have variables in there. So it's really good that you know these like the top of your head. All right, so that is it for, oh, I'm sorry, example 4. Let's rearrange this guy. 5 times 12 equals 60. 5 times 12 equals 60. So 2 fact families here. We know we can flip that multiplication to be 12 times 5 equals 60. And if we multiply in that direction, we divide in this direction. That gives us 60 divided by 12 equals 5, okay? If we multiply in this direction, we divide in that direction. 60 divided by 5 equals 12. So there are our 4 fact families, our 2 multiplication, our 2 division. Okay, now with that said, we are on page 10, and halfway down the page is the practice. It's A through H. What I'd like you to do right now is go ahead and pause this video, go ahead and give those an attempt or a try in your notebook so that we can see, and then come on back when you're ready. Okay, so A is 20 times 37 cents. Well, this one has a 0 on it, so really what it is 37 times 2, right? With an extra 0. So 7 times 2 is going to be 14, 6, and there's 7, okay? So we end up with 740 cents. How would I write that as a dollar? Be $7.40. $7.40. All right, for B, we have 37 times 0. Anything times 0 is a big fat goose egg, aka a 0. So that was pretty easy. C, we have 407 times 37. 407 times 37. This is a 3 by 2, so I'm going to use my box method. And I'm going to do 2 rows and 3 columns. Across the top, I'm going to put 400. Oh, 0. And then 7, because 400 plus 0 plus 7 gives us 407. On the side, 30 and 7. Over here, I've got 3 times 4 is 12 times 1, 2, 3 zeros. 7 times 4 is 28. Ooh, with 2 zeros. 0 times 30 is 0. 0 times 7 is 0. 7 times 3 is 21 with a 0. 7 times 7 is 49. Okay, so now let's do the addition part of that. We have 12,000 plus 2,800 plus, and if I add these two together, that's just going to give us 259, right? 259. Add these guys up, we get 9, 5, 8, and 2 is 10. Carry the 1, we get 15. So 15,059. 15,059. Good work. That was C. So let's look at D now. D, we have 5, and then so we have $8.40 divided by 5. Now we go ahead and bring that decimal up here. How many times does 5 go into 8 without going over? 1 time. 1 times 5 is 5. 8 minus 5 will give us 3. And when we subtract, we bring down. 5 goes into 34 without going over 6 times. 6 times 5 is 30. Subtract that, okay? And when we subtract, we bring down, and we get a 0 here. 5 goes into 48 times, and there is no remainder. No remainder. Okay, so then let's do E. So, it's written like this. I should probably do that. 200 divided by 12, like this. When it's written like that, that first one goes under the table. So it's going to look like this. All right. So how many times does 12 go into 2? It can't, but it can go into 20 one time. 1 times 12 is 12. We subtract that and we get 8. And when we subtract, we also bring down, okay? So I happen to know, but I really should have done this. If you don't know your 12s, it's a good idea to get a multiplication chart just so you can have it handy. I really want you to memorize your multiplication, but if you need a chart, you have it. 6 times 12 is going to give us 72, right? So I'll just show you. 2, 1, 6 times 1 is 1 plus, or 6 plus 1 more is 7, so 72. So 6 times 12 is 72. We subtract that down, we get 8 more. And at this point, we've brought everything down, so it's 16 with a remainder of 8. We'll talk more about decimals and dividing with decimals later. Okay, so for F, we have it written as a fraction, because really a fraction, all it is just division. So F is written like this. 234 divided by 3, divided by 3. Now, if it's on top of the table, it's going to go underneath the table in our new problem. So 3 does not go into 2, but 3 can go into 23 7 times, and that'll give us 21. When we subtract, we get 2, and when we subtract, we also bring down. 3 goes into 24 8 times, okay? And 8 times 3 is 24, therefore we have no remainders. No remainders. Okay, for G, it says, which numbers are the divisors in problems D, E, and F? All right, so looking back at those, and I may have explained, or I should have explained, the divisors are what we're dividing into the big number, okay? Into the big number. So for D, where we had $8.40 divided by 5, this was E. I'm sorry, that was D. For E, we had 200 divided by 12. And for F, we had 2, 3, 4 divided by 3. Okay, so the question asks us, which are the divisors? The divisors, again, are the small one that we're dividing into the big one. So this is going to be the divisor here. This will be the divisor here, and this will be the divisor here, okay? The end result for what we get, that's what's called the quotient. All right, so for letter H, we need to use 8, 9, and 72 to make two multiplication facts and 2 division facts. So 8 times 9, sometimes you'll see me use a dot instead of a little X for times, and that's just to get you used to the idea. We're going to be using that. Once we introduce some variables, it can get a little confusing. So 8 times 9 is 72. We know that we can flip our multiplication around. 9 times 8 is 72. And if we multiply in this direction, we divide in this direction, which means we have 72 divided by 9 equals 8. If we multiply in this direction, we divide in this direction. So we also have 72 divided by 8 equals 9. So there are your 2 multiplication facts and your 2 division facts. Great work. If you have any questions, let me know. Otherwise, I'll see you on lesson 3.